Welcome back. Lesson 6, solving by using quadratic formula. So first of all, remember quadratic formula. Hopefully everybody remembers this formula. But remember, it's all based upon standard form for a quadratic equation. Ax squared plus bx plus c equals 0. And the key here is equal to 0. So make sure as you work through these that your equation is equal to 0 before you start plugging in a, b, and c into our quadratic formula. Okay, another thing when we were doing quadratic formula was b squared minus 4ac. This was called the discriminant. And this tells you what type of answers that we will come up with. Remember, if it is greater than 0, then we are talking about either irrational or rational roots, or we will have two real answers. If it was less than 0, so it's a negative number, then we have two imaginary solutions. And that's because you got the square root of a negative number. Whenever we have the square root of a negative, that's imaginary solutions. And if it's equal to 0, then there's only one real solution. All right, so let's look at example 1. Again, remember your equation has to be equal to 0 before you start plugging in. So example 1, if you notice, it is equal to 0. So the one thing we always did first as we did this was we found the discriminant first. So b squared minus 4ac, here's b. So we're going to go 4 squared minus 4 times, here's a. If it's not there, it's 1. And then times c, negative 12 is c. So if you got your graphing calculator, you can plug this in exactly like you see it. So 4 squared minus 4 times 1 times negative 12. And that'll give us our discriminant. So our discriminant is 64, which means it's greater than 0. There's two real solutions. Whoops. So now let's plug it into our quadratic formula. P is going to be equal to opposite of b, plus and minus, square root of what we just found, b squared minus 4ac, so that's 64, all over 2 times a. Well, 2 times a, 2 times 1 is 2. And then we look to see if we can simplify the square root, which we can. Square root of 64 is 8. So whenever this is a perfect square, I want you to write both answers. So one answer is going to be negative 4 plus 8 over 2, and the other answer is going to be negative 4 minus 8 over 2, and then simplify these as much as you can. Well, if you go negative 4 plus 8, that's 4 on top over 2, which is, so there's one answer. And if we go over on this one, negative 4 minus 8 is negative 12 over 2, which is negative 6. So we got our two solutions there, two real answers. All right, example 2, notice, first of all with this one, that it is not equal to 0 right here. So in order to use the quadratic formula, that's the first thing we got to do. Now that we have it equal to 0, let's find our discriminant. Let's see what kind of answers we're going to get. So b is 2, so 2 squared minus 4 times a times c. And let's plug it into our calculator. So we got 2 squared minus 4 times 3 times negative 1 is 16. So there's our discriminant. We know we're going to have 2 real answers. So b is going to be equal to opposite of b plus and minus square root of what we just found, 16. All over 2 times a is 3, so 2 times 3 would give us 6 on bottom. Simplify our square root, well, we can do that. That is 4. All over 6, so again that was a perfect square. Go ahead and write the 2 answers. So b is going to be equal to negative 2 plus 4. Over 6, and then the other one will be negative 2 minus 4 over 6, and then simplify these. So this one, if we do negative 2 plus 4, that's 2 over 6. Make sure 2 over 6 is in lowest form. 2 over 6 would simplify to 1/3. Then this one over here, negative 2 minus 4 is negative 6. And what's negative 6 over 6? It's negative 1. So we got our 2 real solutions. So both of those examples, if you notice, our answers ended up as what we call rational numbers. So if your square root is a perfect square, like example 1 and 2 were, then you will end up with rational answers. Rational numbers are real numbers. Example 3, we will not end up with rational answers. So let's look at example 3. So again, first step, remember it's got to be set equal to 0. It is not, so that's the first thing I'm going to do. Subtract 6 from both sides. That would get my right side equal to 0, and that's what we want. That'll give us a positive 2 there. So let's find our discriminant. So negative 12 squared minus 4 times a times c. Notice how I got parentheses here. That is extremely important, especially when you're using this graphing calculator. So we want parentheses around negative 12 when we square it. So whenever that base is negative, make sure you have parentheses around it. Minus 4 times 8 times 2. So that gives us 80. Which means it's still greater than 0, so I'm still going to have 2 real answers. Here's the problem. The square root of 80, though, is not a perfect square. So let's plug it in quadratic formula. Opposite of b plus and minus square root of what we just found, all over 2 times a, 2 times 8 would give me 16. So if this isn't a perfect square, we then, at this point, see if we can simplify this. The biggest perfect square that goes into 80, there's several perfect squares that go into 80. You might think 4 does go into 80, but there's a bigger perfect square that goes into 80. 16 goes into it 5 times. So another way to write 80 would be 16 times 5. And then the square root of 16 is 4 times the square root of 5. So that's how it simplifies. And all of that's over 16. So if you remember, we talked about the quadratic triangle the number in your denominator, the opposite of b, and then if we could simplify this radical, the number in front of that radical. That's what we called the quadratic triangle. If all of those share a common factor, then we can simplify it, which they do. The biggest common factor that goes into 12, 4, and 16 is 4. So we're going to divide by 4. Divide by 4 would give us 1 square root of 5, or just square root of 5. And divide by 4. So divide all 3 of these in the triangle here by 4. And there we have it simplified. So if this number in your discriminant is not a perfect square, this is how I want you to leave your answers. You don't have to separate them and have 2 solutions written out like I do up here. We only do that if that number is a perfect square. We still want to simplify it, but we're not going to separate it into 2 answers at that point. All right, last example. We'll deal with one where we got imaginary solutions. So again, it's not equal to 0, so the first thing, add 10, add 10. So at this point, let's find our discriminant. So it's 8 squared minus 4 times 4 times 11. If we plug that in, 8 squared minus 4 times 4 times 11. That'll give us a negative 112. And now, if you notice, this is less than 0, so we have 2 imaginaries. So let's plug it into our quadratic formula. Opposite of b, plus and minus square root of what we just found, all over 2 times a. 2 times 4 would give me 8. See if we can simplify that, which we can. Since it's a negative, the first thing is we can pull out the I, and then see if you can find the biggest perfect square that goes into 112, which again, there's a couple of them, but the biggest one would be 16. 16 times 7. Square root of 16 is 4. So this ends up as 4i square root of 7. So we got negative 8 plus and minus 4i square root of 7. Again, look at that quadratic triangle. Is there a common factor of all 3 of those? There is. It's 4. So divide by 4. Divide by 4. That would just give us I radical 7. Divide by 4, we get 2. So we have it simplified at that point. All right, everybody have a great day. We'll see you later.